Hello, welcome to another episode of Xa Talk Show. Today we are going to do Advent of Code, Day 6. I heard that this problem is easy, so I hope we can do it. I'm gonna do it fast and hopefully we can finish in 30 minutes or 20. Part 1, Part 2. Then I'm gonna start another video, possibly today, possibly tomorrow on Day 7. I heard that Day 7 is a bit more difficult. So I'm gonna code it in Wolfram language. Advent of code. Okay, day 6. So let's begin. Let's double check, video check, audio check. Okay. And if you comments, okay, if you are here, comments and post questions on Wolfram language. Okay, so we are. I'm gonna try to be very focused, and let's just code this thing, Wolfram language. Okay, so Wolfram language. Yeah, so let's begin it. Let's start Wolfram language. Okay, new file. Start the kernel. Wolfram language is free. You can just search for Xali Wolfram language. You'll find my complete tutorials about it and information about where to download and stuff. Okay, Advent of Code number 3. Okay, so yeah, ready? Yeah, ready. Okay, so let's do it. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the starfruit grove. Oh my god, finally. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one is to set up right now is a communication system. However, because he's heard you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you their one more functioning device. Surely you'll have no problem fixing it, so you need to fix some device about signal-based system. As if you know, what do they link to? Jesus. Oh, they link to past Advent of Code problems. Okay, as if inspired by comedic timing, the device emits a few colorful sparks. Comedic timing, okay, Christmas. To be able to communicate with the elves, the device needs to lock on to their signal, okay? The signal is a series of seemingly random characters that the device receives one at a time. So the device receives seemingly random characters, one character at a time. Okay, to fix the communication system, you need to add a subroutine to the device that detects a start of packet marker, okay, in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different, okay? In the protocol is used by the elves, the start of the packet, basically your device receives some signals, a bunch of characters, and the start of the start of a session is start of packet. There's a marker, 4 characters, okay, 4 different characters that marks the beginning of a session or something. The device will send your subroutine a data stream buffer, your puzzle input, okay? Your subroutine needs to identify the first position where the 4 most recently received characters were all different, okay? Okay, specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first search for character marker, okay? For example, suppose you receive the following string buffer, basically a string, a list of characters. After the first 3 characters, MJQ, okay, have been received, there haven't been enough characters received yet to find the marker. Okay, because the marker is 4 characters. The first time a marker could occur is after the 4th character is received. Okay, making the most recent 4 characters MJQJ. Okay, because J is repeated, this isn't a marker. Okay, so you need to find essentially the first 4 unique characters. Okay, so the first 4 unique characters. Okay, the first time a marker appears is after the 7th character arrives. Okay, let's see. 1, 2, 3, 4, 5, 6, 7. So starting with G. So previously you have M, J, Q, P. So you have more than 4 different characters. M, J, Q, P, Q. Hello, Flamio. So the first time a marker appears is after the 7th character arrives. Once it does, the last 4 characters received are J, P, Q, M. Okay, J, P, Q, M, which are all different. J, P, Q, M, which are all different. In this case, your subroutine should report the value 7. Okay, because the first start of packet marker is complete after 7 characters. Okay, so basically for this input, the answer is 7. Is complete after 7 characters. 7, up to 7. Okay, here are a few more examples. Okay, so in this input, the first marker after character 5. Okay, 1, 2, 3, 4, 5. Let's magnify. Okay, 1, 2, 3, 4, 5. The first marker after character 5. So you want to find the first occurrence of a sequence of 4 different characters. Hello, secondary account. Hello, Ryan. I believe, Ryan, I have seen you before. I have seen all of you before. Anyway, back to the problem. So there are some examples. Okay, so let's copy it. Okay, let's copy it. So we go back to Emacs, so it's much easier to see exactly what's going on. Magnify. So it says, okay, so okay, so let's see. So we got these problems. Okay, so it says 1, 2, 3, 4, 5. Okay, so VWBJ is the first occurrence. So here is 6, 1, 2, 3, 4, 5, 6. Okay, so let's mark them this way. So in this case, it's PDVJ. Okay, in this case 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, in this case it's RFNT. Okay, in this case it's 11. 1, 2, 3, 11. Okay, so it's ZQFR. Let's see how it works. ZCFZ, repeat, F, repeat. Okay, the first 4 characters, that's all different. That's all different from each other, and okay, it's so yeah, okay, so FZF, that's not right. ZFWZ, that's not right because there's a repeat. Now let's try this one. NZN, that's not right, there's a repeat. ZNRN, repeat. Okay, so each time you look at 4 characters, as soon as there's 4 different characters, that counts. Then at the end of that is your number. Okay, that's the problem. How many characters need to be processed before the first start of the packet marker is detected? Okay, so that is a problem. Okay, that is a problem. Now let's think, how do you solve this? You want the first 4 different characters. The first 4 different characters in sequence. So all you have to do is you check 4 characters at a time, then you move on by 1 character. So check the first 4 characters, then check the second 4 character, starting with the second index, then start with the third index. Okay, so you just go through the index, the length of the string minus 4 or something. You know, you start with index 0 if your programming language, let's say in Wolfram language, the index start with 1. Okay, so you start with the first character, then second character, up to the length of the string minus 4, something like that, or minus 3. So as soon as you find the 4 characters are different, you stop. So basically you write a loop. Okay, so you can write a loop to do that. Yeah, so check. So given a string, you check the check. Yeah. Okay, let me show you an efficient way to do this. Okay, very efficient. Okay, first of all, let's make this pretty. Okay, so I'm going to show you. This is XAR HTML mod. I'm using Emacs. I'm using XAR flag keys, and this is Exposed keyboard, and this is Vorak layout. You can search XAR flag keys to find my Emacs package, and you can search XAR Exposed keyboard to find my review detail. I recommend. Okay, so now. So you have to do here, let's make a definition list. Okay, so delete that part. Okay, okay, that's our input. That's our input. And okay, so efficient code in Wolfram language. Let's do this quickly. So input. So first of all, you need the input. Okay, so input string. Let's say the input x input equals to, let's just say 1. Okay, that's a string. Okay, I'm using XAR Wolfram mod, which is a Emacs mod that lets me code Wolfram language. I do that in Emacs because it's more efficient to type and manipulate. Okay. Okay, so here's the input. So you string partition. Let me show you how to do this. Okay, Wolfram language. This is okay, that's a function we want, and let's look up the documentation. It will just take a string and turns it into a list of strings, and by cutting each nth element. So, you know, if you have A, B, C, D, then you say string partition 2, it'll return a list of A, B, and C, D. So if you say 3, then it's gonna be A, B, C, D, E, F, G, H, I. If you have a long string, then you can add a offset. So if you have A, B, C, D, E, F, G, then you say partition 2, offset 1. The result is A, B, B, C, C, D. There's one character that repeats. So in this case, we want to partition it. Okay, so let me show you. String partition 1, partition by 4 with an offset of 1. Okay, so this x2, let me show you how it runs in Wolfram language. There it is. You see, let's see, BVFB, then VWBJ, that's right, then WBJP, that's right, you see. Okay, so now all we have to do is map a function to see which one is 4 unique characters. Okay, this is Wolfram language, very different. In other languages, you don't have this string partition. You have to write a loop, which is also very easy. But this is a functional programming in Wolfram language, very efficient. So now you just write a function that map to. Okay, so you just map a function to this list x2, map level 1, we don't care, it's by default this one. So map a function. So what the function will be? The function will be, okay, x is a string. You want to see if each character is 1, it is the same. So let me show you how. Normally you can just take the index of a string, for example, string index, for example, in Python, that then you compare that, then you do this for 0, 1. You want to make sure all of them are different, so you can turn it into a list and test for intersection in Python, or many ways. But let me show you the efficient Wolfram language way. So a function, you want to make sure the 4 different strings are different. Okay, string partition. Okay, so you can simply do an equal sign. So string partition again, partition it that with all string to list. Now string to list is rifle. So let's do partition. Okay, let's do partition just by 1. Let's test it. We can run this code in here. So you see, there is the output. You see A, B, C, D. That's what these do. So now you string partition it. Now you just want to apply the equality test to them all. So okay, let me show you. So that's it. Actually, that's it. That is the solution. Wait. Same queue. You need to replace the head. You may not know what I'm doing, but let me just finish the problem quickly. Okay. If you have questions about this, the Wolfram language, just ask me. Okay. So let's try. Let's try this. Okay, same queue. Let's look up what's the reverse of same queue. unsame Q, okay? What? Oh yeah, the spelling is wrong, so unsame Q, let's see. Unsame, that should return false. That's right. So if you have, then if it's 3, that's true. You see, in Wolfram language, the equality test, same Q is the equality test, okay? It's like JavaScript's equal, or like Python's double equal. Similar, because the equality is very complicated in different languages because it depends on the type, or does it measure the reference of a list, or does it actually test the content of the list, things like that. So equality testing is very complicated in different languages. So in Wolfram language, you have the same Q. Let me show you, okay? So if you go to not English, okay, Sali.info. Okay, that's my website. Okay, so you go down. There's a Wolfram language complete tutorial, and where you can download it for free. Okay, and then you go to equality testing, Boolean true false equality test. So here's all about how do you test equality in Wolfram language. And one particular thing of the equality test in Wolfram language is that you can sequence them, which you cannot do in most languages. Because, for example, in most languages, once you do, for example, A, B, you cannot say C. You cannot do that. Because A equals to B, they will evaluate to true and false. Then true and false, is it equals to C? Then of course not, because C is usually not. So you cannot do that. But in Wolfram language, you can. Okay, so that's a interesting aspect. So that's why we can do this unsame Q. That tests inequality. So for example, it can be anything. So all of them, if all of them, none of them are equal, then it's true. Otherwise, if you have something equal, it's false. Okay, so we can do this one shot, and it will get you the answer. So let's run it. So for this, you see here is true, and so that's it. So, and you want to take the first one. Let's just take the first one then. The first element, that's true. Okay, now the code I'm writing now is not utmost efficient, but I just want to solve the problem first, because if there are a lot of scenarios. Suppose the string is 1 million characters and lots of things like that. I'm not, I want to solve the problem quickly, because otherwise, I have to explain everything. It takes too long. So now you just want to find the first element that's true. How do you do that? You can use the function positions. Okay. Let's see. Extract position. Okay. So you can use extract or get element part, get parts by a filter function. No, you want to know the index of the first occurrence. So cases, okay, get elements by pattern. Okay, we want delete element, change element, sort member. There it is, this function position. So it let me show you. Okay, so position, let's say 3, 4, 5, and if you say 4, it will return 2 because the pattern 4 occurs on the index 2. You see? Okay, so you want the first one because otherwise you want to be efficient. Once you find the first one, stop. Okay, so let's look up. I think there's the. Oh God, what? Is my internet down? Hey, coffee house. Okay, here's position level spec n. Okay, gives the position of the first n object found. So in Wolfram language, if you just need the first one item, you want to give that argument because otherwise it's inefficient. So the level spec is gonna be just first level 1 and return the first item. Okay, for example, let me show this. You see 2 and stop. But in case you have lots of 4s, it still return 2. But what? Oh, Wolfram language improved. Now you can have now extraneous comma actually. Okay, so but if you don't have this one, you see you have many occurrences. So this is what you want. So essentially just put that here and you are done. Okay, so let's try again. You want to test for true. Yeah, so true here. True. Okay, that's the answer. Now let's try the other parts. Okay, so back. So this string is 6. Okay, so this string is 6. Run it. 3. Okay, what? What? Our code is incorrect. Oh yeah, so wait, oh yeah, so you need to add 4. Yeah, of course, you need to add 4 because it wants the end of the position, not the beginning. Okay, so let's try it again. 7, you want to add 3 because this is off by 1. Let's see. Yeah, I'm sure add 3, but let me let's not be let's just get it to work. Let's not be too logical and stuff. Okay, so check. So the third example should be 10. Check. See the bottom? Check. Okay, the fourth example should be 11. Check. Okay, see the bottom? Can you see? Yeah. Okay, so yeah. Okay, good. We solved the first problem. Now let's get the input. Okay, hold on a second. Let's put it back. Let's worry about that later. So let's get the input. I want to finish this quickly. Oh, okay, a big one. This is the input. Now this is a talk show. Okay, close, reopen, go to the bottom, new page, search for event of code. Let's drop it to diet. Copy that, save this event of code day 6, and put today's date. Okay. Okay, so copy that, reopen, copy the link, file path, make a link. Okay, there it is. And now go back, copy the code, okay, and go back to Wolfram language. All we have to do is paste it here. Big string, big wheel of fortune, big chun. Oh fuck, 1100. Are you sure? Yes, I'm sure. Let's just run it. Let's just do it. 1100. Yes, shut the fuck up. That's the right answer, of course. Continue to part 2, okay? Part 2. Now let's, yeah, that's the solution. Color syntax it, showing browser again. So syntax color. So that's a solution. You know, this you can make it one line. Okay, so next. So how long has it been? 30 minutes. Okay, next. So the problem 6 is supposed to be easy. Okay. Okay, so your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages, a start of message marker. So wait, before it's what the fuck is the marker? Before the marker is start of packet marker. You know, it's not a good puzzle. Not a good story, you know, story-like puzzle, because when you do this kind of thing, especially for advent code for Christmas, you know, you want to make it not technical, because he's talking, you know, the way he write the puzzle is insinuating the internet IP TCP protocol. You know, you have packet, you know, like what the fuck is a packet? You know, then now he starts to talk about start a message marker, okay, but if your goal is to write something like Christmas spirit, you know, it's a minor issue, but you know, but ideally you want to avoid this kind of, you know, specialized knowledge about packets, about handshake. He didn't mention handshake, you know, but you know, marker. So anyway, start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Okay. And 14. Okay, so that the second problem is trivial. Okay, copy that. Now let's do part 2. Okay, here's a code, and all you have to do is change it to what, 14. Okay, so instead of 4 it's 14, and instead of 3 it's 13 here, so 14 minus 1. Okay, so let's check some input. Okay, so this input result is 19. Let's double check. Run it. 19. Fantastic. Are you sure? Yes, I'm sure. Now let's get the puzzle input. Okay, okay, where is it? Copy, cut. Okay, back to the Wolfram language code. Now post humongous. Run it. Okay, it's the output buffer is long. Oh my god, the Emacs. Let's go to messages buffer. It's gonna take a while. When you know, this is an Emacs problem. When you have a huge long line, Emacs becomes super slow. Like every operation takes several seconds. You know. Anyway, so there it is. Is that the answer? Same answer? 19. Okay, I think that's the answer. Okay, close it. So you can do that. That will suppress the output. Okay, run it again. Oh, there's the answer. Okay, so somehow yeah, before it was too long. So the answer is that 2421. Okay, it's just Are you sure? Yeah, I'm pretty sure. Let's just do it. Submit. Okay, part 2. Do it. That's the right answer. Complete. Fantastic. So 40 minutes today. So that's it for today. Should I do another one, problem day 7 today, or should I do it tomorrow? Let's do it tomorrow. Okay, so that's it for today, and let's clean up our code so that I don't want this long thing. Okay, so let's just run this. Okay, so the problem is 19. I mean the solution. Okay, pop this out, pop this in. So that's today's talk show. Advent of Code Day 6 in Wolfram language, and let's make it one single line. Okay, so because so now let's talk about something random, fun. Okay, so I started I was chatting with Advent of Code with Zilfer. He mentioned something and very interesting. So he's a scheme Lisp coder. He showed solutions in scheme Lisp. So if you program interesting languages, check it out. And there's a closure, and this guy actually did something extra to draw the things, color them. That's interesting. So anyway, so we were talking about one-liner programming, and that's very interesting. So I actually wrote some articles about it. One-liner. Okay, so check out. You might want to check out my Twitter. You'll see all about one-liners. And I have a challenge. My challenge is that for Advent of Code, any day of this year, because last year, I didn't do any before. So, but I know about this year. So let's go back to calendar. Any of these problems, including those I haven't seen, I can code them in one single line in either Wolfram language or in JavaScript, or I can also do it in scheme Lisp. Okay, but I request you pay me $50 if you want me to see that. But I'm for Wolfram language I'm doing it already anyway. So but I want to mention, so it's interesting problem. Okay, so I started to write an article. One-liners, because I do this kind of thing all day and every day in 1990s. So this Advent of Code, this is fairly silly to me actually, because I've been there. I was young before. So but the coding, so there's one-liner, which is a very popular thing. You check for speed, efficiency, you check for elegance, one-liner. Can you do that in your favorite language? And there's code golf and code obfuscation you probably have seen. So code golf and code obfuscation, their goal is that you want to write a solution in your language to a problem such that your code is minimum count of characters. Okay, and it gets very extreme because there's C code obfuscation competition. It's amazing, but code golf and code obfuscation, those problems, minimum count of characters, that's suitable for procedural languages such as C, C++, Perl. In particular, because those languages, they have wild ad hoc syntax and they have lots of tricks, cleverness, because their programming language is not consistent. So you do all sort of bit map, bit mask, bit operations. You do all sort of tricks. So you have a code, something like that, garbage, but it solves something. Okay, so that's code golf, code obfuscation, very popular. Okay, in year 2000s. I don't know about today, but I think they still exist. For example, there's Vim Golf, which is different, but golf basically means shortest. Okay, so but for functional programming, this kind of thing doesn't apply much because functional programming is usually very consistent syntax. There's not many tricks the way like C or cleverness. There's not many cleverness, but there's a lot advanced mathematics, functional programming, currying, lambda calculus, Y combinator, Y combinator. There's a lot of advanced computer science, theoretical computer science that apply. So for functional programming, you want to try to do one-liner, which does not count the number of characters, but rather your whole program is one single line connected by either nested function or function pipe to each other. No separate function definition, okay? No separate variable. That's what you want to do, and you can do that with functional language. The two essential necessary thing is that the function language must be able to write a function that takes a function as argument and return a function as argument and apply a function with the argument lambda, and this function must be anonymous. Your language must have the ability to define anonymous functions and apply it on the same line. So that's the most essential necessity for the language to be able to do one-liner. And this exercise one-liner is very interesting and critical. Okay, so if you are into Scheme, Wolfram language, Clojure can also do that. I'm pretty sure JavaScript also, they can do that. You can combine arbitrary, big program into one single line. So you want to try to challenge yourself, see if you can do it. Okay. For the advent of code this year, I would say problem number 5 is the key. I mean, it's starting to get non-trivial. Problem 1, 2, 3, 4, you can do in one line easily. And also number 6, number 6 is just, today we did. So, but problem 5, it will take some ingenuity. It will take your mastery of that particular language, Scheme, Wolfram language, or Clojure. But however, Common Lisp and Emacs Lisp cannot do it. Okay, I'm telling you, this is interesting fact. So you can challenge me, show me you can, yeah, Common Lisp and Emacs Lisp, you can really do it because anyway. So that's it for today. Thank you guys for watching. If you like my stuff, go to my website. Okay. Pay me. Okay, so there's PayPal, Amazon gift card, or Patreon me. Amazon gift card, it needs to be Amazon USA, not Amazon Germany, France, or because I cannot get the money. Okay, thank you guys for watching. Bye. Oh yeah, so to make this one line, all you have to do is you just move this to this X to here, and that's it.